Let us start with this solution of the first internal question papers, and here we can see that these two, you can see that between these two nodes this is shorted, so this resistance doesn't have any meaning, right? So we can remove this thing. So what we can do in the circuit, we have removed here, and the same thing, this thing's whatever is here, this is removed, and we have removed it and shorted now this. Now it is very clear that in this second figure that between these two nodes we have, from the right hand, this is the two resistors are there, and they are supposed to be in parallel because starting from here and ending over here. So these two resistors are in parallel. So let us remove that with a single resistor. So I remove that, and we will remove it by a single resistor. That is what will be, it will be 1 into 6 by 1 plus 6, that is 6 by 7. So this will be 6 by 7. Now this looks very complicated because of there is another resistance here, this resistance is here, and that makes it a little bit of complicated. So what, let us do one thing, let's remove this one and let us add a resistance like this. It's mean the same. What I mean to say is, if I remove it and add a resistance like this, it means the same. So for that I will just remove this, and we will add a resistance like this here. The same resistance 6 ohm is taken out, and like this. Another thing to be noted is that you can see that this 6 ohm is like connected in this way, and these two nodes are same. In order to remove the confusion, so if I remove this 6 ohm from here and I will draw it like this, so this means the same. So now this is very clear, and that these two, between these two nodes we have got one resistance here, one resistance here. So these two are in parallel. That means these two resistance in parallel. So we can calculate the parallel resistance, 6 by 7 into 6. So here it will be 36 by 42 plus 6, right? So this will be like, so 3 by 4 ultimately. So we can write this as, remove this, and draw like this, 3 by 4. Now these two resistances are in series, so we can write down that as 3 by 4 plus 2, 11 by 4. So we can remove it and make it like this, 11 by 4. Now here we can see that these all three resistance are in parallel. So we can calculate all together, or we can do like this, we can solve these two first, then we can solve with this. If we solve these two first, it is 3 into 6 by 3 plus 6, that is 9. So this will be 2. So together we can remove these two, and we can replace it by a resistance 2 of 2 ohm. Now this 2 ohm and this 11 by 4 are in parallel, so we can write that 2 into 11 by 4 by plus 11 by 4 to 22 by 19. So 22 by 19 volts. So we can remove this and write it as 22 by 19 ohms. Now obviously these three resistances are in series, so we can add up these two. So 22 by 19 plus 2. So that is obviously this much. So this is, so we have a 60 by 19 as answer. So that's much of ohms. And so the answer you have got, RAB is equals to 60 by 19 ohms. This is the answer. Next we have this question that find out the voltage across VAB, VBC, VCA, and then finally asked not CA, VACD, then finally what is VDA. So what we can do is that to verify the answer, these three sum must be equals to the opposite of this VAD, because VDA is equals to minus of VAD, so they are equal, right? And let us solve it by KCL KVL. So applying the KCL KVL, what we have to do is first you give the direction of the current. Let us say the direction of the current is like this. So we can see that the current will not go on the from C to B. So this current will go in this way and it will go up like this. So here after applying the direction of the current, we have to give the sign convention. So we get a sign convention across all. So obviously for the voltage there is a plus minus like this, and for the current first plus then minus, for resistor plus and minus. Okay, and here on that this side we have no current, the current is not flowing over there, so only the sign will be there, so that is plus and minus, correct? And let us apply KVL. Applying the KVL in the path DCAD. So in this closed path we are applying the KVL. So we will get the equation like 20 plus 1 into I. Similarly 1 into I plus 2 into I minus 10 plus 1 into I is equals to 0. I can quickly write that this is all 2 plus 1 plus 1, for this 4, and this one 5. So I can write 5I plus 10 is equals to 0. So I is equal to minus 2 ampere. So current is now known to us. Now we will just find out the value of which is asked. First is VAB. So AB is where? This is A and this is B. AB is asked, so just move from here to here, right? Just add all those things. That is first come minus. So minus 1 into I plus 20 is equals to how much? Put the value of the current. So this is 2 plus 20. This is 22 volts. That's the answer of VAB. Next is VBC. Where is BC? B is here, C is here. So that's very easy. So this drop is nothing. So only what we have is the minus 20 volts. So this is minus 20 volts. VCA. VCA, here we have C and A we have here. So just move in this way. So we can get it is 1 into I, that is minus 2 volts. Now VCA is not asked, rather it is asked that what is VCD. VCD, C is here and D is here. Move in this way. You get minus first, then minus again. So we can write minus of 1 into I, minus of 20. So current is negative, so this will be 2 minus 20, that is minus 18 volts. And next is asked what is VDA. So D is here, A is here. So I can move in this way or I can move in this way, both are correct. So let us move in this way. So we get a minus I plus 10 minus 2I is equals to, since the current is negative, we get a value of here 2 to the 4, here 1, 5. So total 5. Plus 10. Just a minute. Here one mistake. This is not 5. The other it is this is 4, and this is 2. So 6. So total is 16 volts. Right. Let us verify that. If we add this value of VAB plus VBC plus VCA CD, it will be coming around. So 22 plus minus 20, that is 2. Then this minus 16. So we get it minus 16 volts. And VAD is minus 16 volts. Similarly, VDA is equals to 16 volts. So that should be the answer, 16 volts, and here we are also getting 16 volts. So these four are the answers of this question number 2. Okay. Next, what we have is this question. Uh, the question is asked about solve the problem by using mesh analysis. So solving this in mesh analysis, here we have a number of meshes. How many meshes there? 3 meshes there. 1, 2, and 3. So I1, I2, I3. So if we apply the mesh analysis here, so obviously I1 is equal to 5 ampere, because in this mesh 1 there is a current source, and obviously the current which is flowing in mesh 1 is 5 ampere. Similarly for mesh 2, we have got this mesh. So applying mesh analysis there, we can easily write, so 1 plus 5 plus 2, that is 8 I2 minus I1 minus 2 I3 is equals to 0. This is equation 2. Equation 1 is here. Equation 2 can be easily converted into another equations we can add. Just putting the value of this I1 in here. Here. So we can write 8 I2 minus 2 I3 is equal to 5. This is equation 3. Or we can write equation 2a. Next we have the third mesh. So this is for mesh 1, mesh 2, and let us write for mesh 3. In mesh 3 we have 5 I3 minus 2 I2 is equal to minus 20. So this is equation number 3. So now we have got two equations, this and this. So using these equations and two variables, we can get the value of I2 and I3. Let us solve it. Let us multiply both on the bottom, top and bottom by I3 is over here 2 and this is 5. So here we multiply with 5 and here we multiply with 2. So 40 I2 minus 10 I3 is equal to 25. This is 10 I3 minus 4 I2 is equal to minus 40. Solving it, adding both, we will get 36 I2 is equal to minus 15. So I2 is equals to minus 15 by 36, or minus 5 by 12. This is the value of I2. And if we know the value of I2, so I3 is equals to, I3 will be equals to minus 20 plus 2 I2 by 5. Okay, let us keep this 5 here. So we just rewriting this equation once more. So putting the value of I2 here, minus 20 plus 2 into minus 5 by 12 minus 5 by 6. This will be equals to 120 plus by 6. So minus 125 by 6, that is 5i3. So I3 is equals to minus 25 by 6 ampere. Now we know the value of I2, minus 5 by 12. So what we get is I2 is equals to minus 5 by 12 and I3 is equals to 25 by 6, minus 25 by 6, or this can be said as minus 50 by 12 ampere. So what is the value of I? So I will be equals to I2 minus I3, and that will be equals to I2 minus I3 will be minus 5 plus 50 by 12, that is equals to 45 by 12. So divisible by 3, so this is equal to 15 by 4. So 15 by 4 ampere is the answer. So we can write that the answer to this is 15 by 4 ampere, right? So this answer is 15 by 4. Next we have is solving by using node analysis. So node analysis, we can solve this by taking the nodes over here. Let us say this 1 and say this is A is written. Let us remove that for a while and let us solve first by using node analysis. So solving this, we can write for node 1, we can write this equation, that is minus 5 plus V1 by 1 plus V1 minus V2 by 5 is equals to 0. Second equation for node 2, we have V2 minus V1 by 5 plus V2 by 2 plus V2 minus 20 by 3 is equal to 0. These two. So solving these two equations, first equation we can rewrite as V1 6V1 by 5 minus V2 by 5 is equals to 5, or we can write simply as this 5 will remove and this is will write 25. So we can write here 6V1 minus V2 is equal to 25. This is the first equation, correct? And another equation we can redrawn from this equation 2, that is V1 by 5 plus V2 1 by 5 plus 1 by 2 plus 1 by 3 is equals to 20 by 3. So this can be written as minus V1 by 5 plus 36 plus 15 plus 10. V2 is equal to 20 by 3. One by 30, V2 is equal to 20 by 3. So we can get here minus 6V1 plus 31 V2 is equals to 200. So we get these two equations. So if we just add this to equation here, this is, let us say, equation 3 and this is equation 4, this V1 will cut down and what we get is 30 V2 is equals to 225 and V2 is equals to it is divisible, right? So 7, 515, 7.5 volts. So V2 is 7.5 volts. So once we know the V2 is equal to 7.5 volts, we can find the value of the current in this wire. So this current is 7.5 minus